Hello everyone. Today I'm going to give you a review about how to use Cisco Packet Tracer to simulate a network. So first we need to select a desktop machine from end devices. So I select 1, 2 PCs. I need to select another set of PCs, for example another PC here to build a second LAN. I need the 2 switches. The first switch I will use the model 2960. I bring it here. Second switch I'll bring it here. Now these 2 switches basically they will be needed to connect the PCs to form a local area network. I can also edit the name of the switch. For example, this one I call it switch 1 and this one I call it switch 2. Alright, now we need to connect the PCs together to the switch. Go to connections, select the straight cable, and then bring connection from PC1 to using fast Ethernet 0 or the network interface card to any port on the switch. And then I go to PC2, select the network interface card and connect it to any available port on the switch 1. We can do the same thing for the other LAN, but in that case, instead of clicking each time on the cable, straight or cable, I can press on control like this, and then I click on the cable like that. I will connect the PC3 to switch 2. I don't need to come back again any port on switch 2, and then I don't need to come back again to select the cable. I just go to PC4, connect from the network interface card to any available port on switch 2. Having done that, now we build 2 LAN. So I can use the note here just to specify that this is LAN 1, and here I write LAN 2. Now the second portion of this design, I need to include a router. So now I go to routers, I click on routers here at the left bottom of the screen as you see, and then I select a model of the router, let's say 2901. Let's go for 2901. I put it here. Now I can change the name of this router and call it RT. Okay, that's very simple. After that, if I put a mouse here, I can see all the interfaces available on that router, and here it shows that it has a gigabit Ethernet 00 interface, which is down, of course not used. It has a second gigabit Ethernet 0/1, which is down, not used. Now what I do, I go back again to the connections and I select the straight through cable. I press on control key, then I click on the straight through cable here. Then I come to the router, I go to the router, and from the router I connect the gigabit 00 port to any available port on the switch 1, and I click any available port or the second gigabit Ethernet interface 01 to any available port on switch 2. So like that I finished my design of the network. What I can do, I can press escape to release this. Now I can, for example, specify the IP address for PC1. For example, I'm going to use IP address 192.168.0.1/24, which is a subnet mask. I can select this, copy C, copy V, control C, control V, just to copy the IP address. Here I will change the host name to 2, for example. Same story on the other side. I'm going to select 10.1.1.1/24, for example. Control C, control V, just to, instead of writing again and again, it's just easy to copy and paste. And here I'm going to change this to 2. Okay, this will be changed to 2. So now I have specified the IP addresses for each host. Now I need to specify the IP address that I will assign to the interface of router that will play the role of default gateway for these 2 LANs. For example, the gigabit interface 0/0, I'll grant him an IP address 192.168.0.100, for example. I always keep the subnet mask which is /24. And for the second gigabit interface 0/1, I give him an IP address. I give it an IP address 192.168.0. Sorry, This is a different network. It will be 10.1.1.100 and the same subnet mask /24. Now I have assigned the IP address to each one of the interfaces of router RT. Now this IP address assigned to this interface gigabit 0/0, which is 192.168.0.100, will be the default gateway IP address with respect to hosts in LAN 1. This IP address assigned to gigabit 0/1 interface will be the default gateway IP address for hosts on LAN 2. Now I start configuring PC1. So that's very simple. I go to PC1, go to desktop, IP configuration, and here I choose the static configuration. So here manually, I have to enter manually the IP address to PC1. So what is the IP address in this case? 192.168.0.1. The subnet mask will be 255.255.255.0. Okay, I'm using the default subnet mask for this type of IP addresses. And here I have to specify the default gateway. What is default gateway? As we said before, it will be the IP address of the interface of a router which is connected to the same LAN, which is 192.168.0.100. So we're done with this. We can go back to command prompt, and in command prompt I can type the command ipconfig and see the IP address 192.168.0.1, right? Subnet mask and default gateway that I just configured. I go now to PC2, do the same thing. I choose ipconfig, and then I type the IP address of PC2, which is 192.168.0.2, default subnet mask, and the default gateway, which is 192.168.0.100, which is the IP address assigned to this interface. When I'm done, I will choose the command prompt, and I just want to configure to check my configuration, check if the IP address are correctly assigned to the PCs, the IP address, subnet mask, and default gateway. Now, when I'm done with the first LAN, I go to the second LAN. I select PC3, do the same thing. Go to desktop, ipconfig, and then I configure manually the IP address for PC3, which is 10.1.1.1. Now, the subnet mask is different from the default for this type of IP addresses, so I have to edit the subnet mask and give the subnet mask as I specified here. Default gateway will be the IP address of the interface, gigabit interface 0/1 of the router, which is connected directly to the same LAN 2, or to the switch which is implementing LAN 2. So I give this default gateway IP address 10.1.1.100. Alright, same thing also. I go back to command prompt, I type the command ipconfig just to check if the IP address and subnet mask and default gateway are correctly configured. I go now to PC4. Now in PC4 I do the same story. ipconfig. What is the IP address of PC4? 10.1.1.2. Now I just configure it here, 10.1.1.2. Subnet mask will be different from the default, so I better use the one that I specified, of course, and default gateway will be this IP address again, 10.1.1.100. Right, okay. Now, why we are specifying this, we have to understand something. Now, if PC1 wants to communicate with PC2, there's no problem. He can deliver the packet through the network interface card. It's network interface card, and the packet will reach PC2 because they are connected to the same LAN. Now, if PC1 wants to communicate with PC3 or PC4, the packet then will be forwarded to the default gateway IP address that we specified, and it happens that it is the IP address of the interface of router. Once the router receives the packet, then the router will be responsible of forwarding the packet to reach the destination. This is very important to understand this concept. So we have here two types of hosts. We can say we have first the local host, those hosts which are connected to the same LAN. For example, PC2 local host compared to for PC1 connected compared to PC1 with respect to PC1, if I can say so, and PC3 is a remote host with respect to PC1. Remote host with respect to PC1. So now, if PC1 wants to communicate with PC3 or PC4, he should send all the traffic through the router to the router. And if PC1 wants to communicate with any host on the same LAN, he simply forward the packet through its network interface card to the LAN, and then the packet will reach the destination host on the same LAN. Now, we need a second part of this. The other part of this demo is to show how to configure the Cisco router. Here I choose the 1901 router, or the 2901, sorry, the 2901 router, and I will show you how to configure that. So the first thing, we can start the router. We have two ways of doing so. Either we go directly here, we click on the router, then we jump to the command line interface, and we start configuring the router from here. Or what we do, for example, let's do it for this time. We bring another host, because we can use any one of the hosts available here, but let's bring another host. And let's say that this host is simply used for configuring the router. Let's call it management. Okay, management host. Now, in order to configure the router from this machine, which is not connected through a LAN, what we can do, we can use a rollover cable. So we connect a rollover cable between the management computer and the router. So let's go to connections and choose a rollover cable. Generally, the color of this cable is blue. So let's pick this console cable, or we call it also console cable. It's a rollover cable. I click on management machine. And here I don't choose faucet Ethernet 01 because I'm going to connect it to the console port. So I will use RS-232, which is a serial interface. By the way, this cable is a kind of serial cable. So I will connect one end of the cable to the RS-232 and the other end of the cable to the console port of the router. I will choose the console port. So if you want to see the console port, just go to physical, and then we can zoom in and use the console port available. This is the console port. It's in blue. The console port is blue, whereas the auxiliary port, you can access console port through the telephone line. Generally, it's in black color. Now, of course, we're going to go to the PC, management PC, double click on it, or click on it simply, go to desktop, and here we click on terminal. Once I click on terminal, I have to make sure the bits per second, data bits, parity, no parity, stop bits, and flow control. If you connect to the console port, there is no flow control, so here you put none. But if you choose to connect through the auxiliary console, sorry, you have to select hardware flow control, because the difference between the console port and the auxiliary port is that the auxiliary port integrates hardware flow control, because this port will be connected through the telephone line, so it needs some kind of flow control. Generally, it's hardware flow control, which is integrated. So now, I just click on OK, and here I am. So I'm accessing the iOS of the router, or the router through its iOS from the terminal on the PC. Now let me just increase the size of the window to make things clear. I press on Enter, and here I am. I'm talking to the router. So the first thing you notice here is that you notice this prompt, router prompt. The name of the router is router, the default name of router is router, and then you see the sign here, the greater sign, which indicates that we are in, let me try this, we are in the user exec mode. This is the user exec mode. So basically in this mode, while we are in this mode, we are limited by the number of commands, the number of functions we can execute. This is similar to the normal user on an operating system. So, for example, in this mode, while I am in this mode, I need to move now to the second mode, which is the privileged exec mode. The privileged exec mode, from where I can configure my router. So, how to move to that? We have to type the command enable. When I type the command enable, so now I'm moving to the privileged exec mode. All right, this is the privileged exec mode. Right, I am now in privileged exec mode, and from here I have control of the router. What I can do, for example, I can configure the clock. I can type the command show clock. What is the clock? What is the time? You see now the time is the default time that comes with the iOS or Cisco routers. I can configure the time. For example, I type CL, but I forget the remaining of the command, so I can help myself with the help editor, with the help available in the Cisco iOS. So I will type question mark like this. So it gives me that, it tells me that there are two commands which start with CL. You have clear and clock. Of course, for me, I'm interested by clock, so I continue. I type clock. Right, now I forgot the remaining of the commands. No problem. I just leave a space because there will be another argument. So I leave a space and then I enter the question mark like this. There is a command set, so I will type command set. Still, I'm not sure about the remaining parts of the command, so I leave a space and I type question mark. Here it gives me the format in which that I should use to enter the time. So the time should be entered in the format as specified. For example, the time is, let's say, 9 hour and minutes. For example, is about 9 o'clock, and second 0. Okay, by the time I finish, it will be 9 o'clock. Now, again, I'm not sure about the remaining parts of the command, so I leave a space, type question mark, and here it says that you should specify the day of the month and the month itself. So the day of the month, okay, I can put, for example, 1st October, okay, 1, and October is 10, Gregorian calendar. When I type this, it says a mistake, and you see the hat sign here indicates exactly where is the problem. It indicates that at this level here, there is a problem. Why? Because I come back again, I tap question mark, and it mentioned here that the month should be entered using the name of the month. So I will say October, okay? October is sufficient. I tap question mark, now it works fine. Now I should type the year will be 2013. Is there anything I should type? No, I'm done. Now when I go back again, I type clock, show clock. What is the time? It is 9:07, Tuesday, October 1st, 2013. Of course, in UTC, Universal Time Clock. We'll see later on how to configure this. Now, after that, from the privilege exec mode, I want to move to the global configuration mode to configure my router, to start configuring my router. Before that, let's see what are the commands available at this level. What are all the commands available? So I can just type question mark as you see here, and you can see all the commands available in the privilege exec mode. Whereas if I want to come back to the user exec mode, I just type disable. Okay, sorry, this command disable will send me back to the user exec mode. Let's type question mark and see the commands available. You see the number of commands that can be executed from the user exec mode is less than the number that can be executed from the privilege exec mode. And remember, this is just a simple simulator. In the real router, you will see that the number of commands that can be executed from the privilege exec mode is much more important. Now I come back again to the privilege exec mode, and then from here I move to the global configuration mode. To do that, I type configure terminal. All right, now you see this prompt here indicates that we are in the global configuration mode. Global configuration mode, okay, global configuration mode, I am there. The first thing we do with a router, actually, it's very important, is to give it a name. Let's assign to it a name. We use the command hostname. And then hostname, which name we have used in our simulation? We have used the RT. Okay, we have used RT. So let's give it hostname RT. Right. Once I press enter, you will notice there will be a change in the router name, the name of router. I press enter, and you see automatically here, immediately the name of router is changed to RT. Now, after that, I need to protect my my privilege exec mode with a password. So I will do this, enable password, and then I give it, for example, the password Cisco. Can do that. I press enter. There is another thing. I can always use this Cisco password if you type show running configuration. Okay. Okay. do show running configuration. Okay. I notice that I press enter. No, still the same thing. It is not okay. Let me just exit, and then I type show running configuration. Now, what you notice about the password Cisco is that it is stored in clear text. The password Cisco is stored in clear text. I don't want that. I just want to save my password, the privileged exec mode password, encrypted. So for that, instead of using enable password, I will use enable secret. Enable secret password. And then I can use another password, let's say class. Okay. Now, actually this command that I used here, you can execute it on the real router, but in Cisco Packet Tracer, it seems that it cannot be done, it cannot be used. Now what I do now, I type show running config, and you see when I type, I see that the class password, the password that I introduced with enable secret is encrypted. That's why that this command is much more important, much more interesting when used. It's better than the first one. So if you have the choice, better use enable secret to protect the privileged exec mode rather than enable password, because the password will be simply encrypted. Now, in case you configure the two commands, use the two commands on the same router, the enable secret will have the precedence over the enable password. So next time you want to access the router, you simply have to type class password instead of Cisco password. Okay, so you have to type the whatever password you type it with command enable secret, because it has the precedence. Now I'm done. Now I go back to the global configuration. You see now I'm using the shortcut. So instead of writing configure terminal, I write conf t, and Cisco iOS understand that I want to move to the global configuration. Now the next thing, I want to protect my console port by typing this console 0, and then I provide the password. The password will be Cisco, of course, and I have to put login. So each time I access the router through the console port, the router will prompt me for the password. That's why I put here login. I can do something else. From the same level console configuration mode, I can go to the line, to the VTY configuration mode. I can type here line VTY 04, and then I put a password, for example Cisco, and the login will be there, the command login. I will enter it. Now if I want to access the router through the console port, the router will prompt me for the password. If I want to telnet to the router using telnet or secure shell, also the router will prompt me for the password. This is to make sure that my password is secure against any unauthorized remote access. Once I've done that, I go back again to the user exec mode, to the privileged exec mode, sorry. You see here the hash sign, which indicates the privileged exec mode. I type the command show running config, and then I can see the password that I entered using enable secret, and the password that I entered with the enable password. I can see also the password that protects the console port and the VTY port. But as you notice, these passwords are in clear text. So in case you want to encrypt this password, there is no problem. Let's go back to the global configuration, and here you have to type a command service password encryption. So once I execute this command, I press enter. Let's go to the privileged exec mode and type the command show running. Look what happens. The previous password which was entered with the enable password is now encrypted, and the password that I entered for the console port and VTY lines are encrypted also. So typing the command service password encryption, this command will enable to encrypt all those passwords which are still in clear text in your configuration file. Now after that, what you can do, you can simply enter the banner. For entering the banner, you will do this. Banner, you type the command banner, then message of the day. And here I have to write sentence, but make sure that the sentence will be delimited by characters. Those characters should not be found on the sentence that I'll be writing. So the best thing to do, for example, I use $, and say, okay, for example, access to this router is tracked, for example. Okay, I'm tracking access to this router, and I have to finish or end up this sentence with the delimiter, the same delimiter $sign that I use. So I will use a $sign here. Here I am. So I entered that. Now I can go back to my exec mode. See, I go back to exit. I exit. All right. So next time I will try to access my router, the first thing I will see is the banner message, the message that I entered through the banner. Access to this router is tracked. So I know that whenever I try to access the router, the access is recorded. So now I'm accessing the router to the console part, so I have to use a password. The password that we configured is Cisco, and you notice that when you type the password, you will not see it. The password is hidden, actually. You will not see the characters. This is normal. Now I am in the user exec mode. I am in the user exec mode of the router. You see the greater sign. Now I want to move to the global configuration mode, to the privileged exec mode. I have to type the command enable, but you remember we typed two passwords. The first one is Cisco. Let's use it. You see, it doesn't work. Why? Because this password is not secure. And the second one that we typed with the command enable secret is, I think, if I remember, is class. It's class. Now you see it works. I go directly into the privileged exec mode, and here I am. I can see my running configuration. Now, the next step, I need to configure my the IP address that I assign to my interfaces. So as you remember, we have how many interfaces? We have two interfaces, gigabit Ethernet 0/0 and gigabit interface 0/1. These are the two interfaces that we configure, that we specified in the design of the network. So in order to configure these two interfaces, I need to move to the global configuration. No way. We have always to go there. Configure terminal, right? From here, I'm going to say interface. Why I'm doing this? Each time I type, for example, interface, I press on tab. Tab will allow iOS to continue the command for me if there is no conflict with another command that starts with the same characters. So I press on tab, and then I say gigabit Ethernet. I press on tab also, tab key, and then I specify which interface I mean, 0/0 interface. I press enter. Now I'm in the interface configuration mode. The next step, I type the IP address. IP address is 192.168.0.100. I should type the subnet mask. Okay, the subnet mask is there. We should not forget the interface. By default, the interface are down. They are disabled. I have to bring the interface up. I type no shutdown, no shutdown. So normally the interface will be brought up, is brought to up state. Okay. Once I finish from the interface configuration mode, I move to the second interface, gigabit interface, no problem. Okay, interface, but you have to type the complete command, interface gigabit Ethernet 0/1. I press enter, then I specify the IP address, which is 10.1.1.100, and the subnet mask is 255.255.255.0. Again, I have to bring the interface up. I type the command no shutdown. No shutdown. My interface is brought to up state. That's great. Now, normally, if I want to check my interfaces, I type the command show interfaces. But of course, it will show you all the details regarding your interfaces. I'm not interested by that. I want to see a summary of what's going on. I type the command show interfaces and brief. I use brief at the end. Show IP interface brief. Sorry, show IP interfaces brief. And then here I am. It gives you the summary about all the interface. Here it says that gigabit Ethernet 0/0 has this IP address. The method, this interface was configured manually by entering the IP address through typing it. The status of interface is up, the protocol is up. The second gigabit Ethernet 0/1 interface has been assigned this IP address, okay? And the method is manual, so we did not use DHCP, for example, so everything seems okay. Now, at the end, I can also type show version to see the information about this router. For example, show version is a command that shows you the iOS software, the platform. So I'm using 2900 software. This is the version. Well, I'm not sure because I'm using the router 1900, but it seems Packet Tracer is giving me this result. This is the name of the iOS and the version 15.1. Here it tells you the system image. It gives you the system bootstrap, the version 15.1. The uptime for the Cisco router is 9 hours. So remember, it's just simulation tool. Here, system image, it tells you from which iOS router has booted. It's booted from iOS stored on flash because it can boot also from iOS, which is stored on a TFTP server on the network. Here it shows you the amount of RAM, DRAM, dynamic random access memory. It gives you also the amount of NVRAM and the amount of storage for compact flash. So all this information can be obtained from this when you type the command show version. When I'm done from the router, I can ping my computers. So remember, the computers, the IP address was 192.168.0.1. Does it work? Normally, yes, it is replying. You see success rate. So next time I ping, it will reply. We'll have 100% of success. Now I ping second machine PC2. Same thing. We'll have maybe 80% of success, but always this happens. Next time I get this 100% success. Now I ping the PC3 and 4 10.1.1.1. You see it's working, right? Fine, it's okay. Next time I ping PC4, same thing, it's working fine. I'm not using PC4, I have PC4, but the address will be 10.1.1.2. Let's see what happens. Yes, it's working fine. So now everything is okay. Let's go back and see the configuration. The configuration, here is the configuration with the IP address of the interfaces, the banners, and the password for the console port, and the telnet and SSH. Now what I need actually, I need to save. Do I have any backup copy? I type show startup. Show startup is a configuration that normally should be available, in the NVRAM. When I type this command, it says that startup config is not present. It means that I did not save a copy of my configuration. That's why I have to do this, copy running startup. So even if I turn off router and I turn it on next time, I will have this running configuration available. So now I press enter. The destination file name startup config, yes, I press enter, yes, here it is. Now I'd like to display my startup config. Okay, there is now a backup copy of running configuration saved in an NVRAM, non-volatile RAM. So remember, non-volatile RAM is like a RAM, except that when you turn off the device, the configuration will be saved there, simply because the NVRAM will keep the information, because it will have a battery integrated inside. So it will store the information. The information is not volatile. That's why we call it a non-volatile RAM. So next time I turn off an on router, the router will load the configuration from the NVRAM. If it does not find the configuration in NVRAM, it will simply request you to enter configuration by hand, like what I have done, what you have seen in this video. Okay, so we have seen how to save the configuration by using this command. Now after that I will exit the terminal. I go back to my design. While I'm in my design now, I go to PC1. I'm in PC1. So the first thing, I ping to localhost, which is connected to the same LAN, which is 192 PC2 192.168.0.2. All right, does it work? Yes, it is pinging fine. It's pinging. Now, what about if I try to ping a remote host? A remote host with respect to PC1, it will be PC3 or PC4 because they are located on different LAN 2. Now, what about now if I ping PC3 10.1.1.1? Does it work? Yes, you see now it's working fine. And PC4, I have to write 2 here. Okay, Now it is replying, so everything is working fine. It is replying, and you see. Now if I want to make sure that my traffic is going through router, I can use the command traceroute, trace RT for Windows platform. On Unix, Linux, you can write traceroute like this. But as long as you're using the Windows platform, you have to type trace RT, and then you specify destination IP address. Okay, so now you see the route. Here it says that the first entry shows the default gateway or the first router, which happens to be your default gateway, 192.168.0.100, and the second entry is simply the destination. The same story if I can do this with the PC4. So it shows you the same thing. So this is a proof that my packet is going through a router, so it has two entries. But if I trace route to a host on the same LAN, look what happens, 192.168.0.2. It just gives you one entry, which means that my packet is not going through a router, but it's simply delivered to the LAN where to reach the destination, which is directly connected to it. Now, can I see the routing table of this PC? Let me just type this route print and see if it is supported, or netstat -r. Well, I can use netstat -r. It seems the first command is not supported. Now here it gives you the routing table of your PC. It means that your PC says the following: if you want to reach any network which is not specified in the routing table, just send the network to default gateway 192.168.0.100 through this interface 192.168.0.1, which is the network interface card of PC1. Now let's go back to router RT. Now while I am in router RT, you see, well, this time I'm accessing the router directly without using the terminal from the management PC. Let me just type the routing table. So show IP route, show IP route. This is IP route. This is routing table, sorry. Now the routing table, in the routing table of RT, it says the following. We have the following. These are destination networks. So destination networks are directly connected. 10.1.1.0/24, this is destination network of LAN 2. This is network of LAN 2. And network 192.168.0.0/24, this is LAN 1. And these are destination network addresses which are directly connected to the router and reachable across the interfaces as specified here. So if the router wants to reach network 192.168.0.0, it simply has to forward a packet through its gigabit Ethernet 00 interface. If the router needs to forward a packet to this network 10.1.1.0, it simply has to forward a packet through its gigabit Ethernet 0/1 interface. But what is interesting with the iOS version 15 is that it specifies new types of routes. Actually, it includes or inserts new entries in routing table, as you see L. L stands for local route. Local route actually is nothing but the route to its local interface. Its local interface. For example, let's see this. L indicates is local route, which indicates the entry to 10.1.1.100. This is a directly connected interface of the router, which is the gigabit Ethernet 0/1. And look at the subnet mask, it is /32, which indicates the IP address, the full IP address for that interface. The second local interface here indicates the IP address of the gigabit interface, the gigabit Ethernet interface 0/0, which is 192.168.0.100/32. So these two types of entries have been included in the routing table of Cisco Router starting from iOS version 15. So they just simply specify the IP address of their interfaces connected to different LANs or WANs. So I hope this video has been useful. Thank you for watching. This is Hakim Adish.